All right, good day, everyone. Thank you for joining us for this webinar presentation. My name is John Clements, and I'm the technical lead for the Homeland Defense and Security Information Analysis Center, or HDIAC, one of three IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, or DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. HDIAC supports those working in the Homeland Defense and Security domains of DoD research and engineering. We do this by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. We provide research and analysis services to help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar and that it serves as a catalyst for community collaboration and improved DoD Homeland Defense and Security research. Before we begin, I will note a couple of administrative items. First, if you're dialed in by phone and would like a copy of the slides, they were posted to the HDIAC webinar announcement. You can go to hdIAC.org/webinars and find today's webinar. When you click on it, at the bottom of the announcement, it will say to view the PDF, click here. Second, all participants are muted, but you can chat with the presenters and moderators using the chat box to the left. However, if you would like to pose a question for the Q&A session at the end, please use the audience questions tool at the top center of your screen. It is the icon that looks like a chat bubble with a question mark next to the emoji. At the end of the presentation, I'll go over the Q&A, and for the benefit of those on the phone, I'll read the question out loud to the presenter. If you have any technical issues during the presentation, do not worry. The full presentation will be available online. You can check back on the HDIAC website, and once the webinar is posted, the Go to Webinar button will take you to the YouTube link. With that, we are happy to present the Interagency Modeling and Atmospheric Assessment Center, presented by Dr. Andy Groves. Dr. Groves is a physical scientist at the Defense Threat Reduction Agency in Fort Belvoir, Virginia. He's the contract officer's representative for the Technical Reachback contract, which comprises a group of approximately 45 CBRN-trained contractors that work 24/7, 365, performing hazard prediction modeling in support of DoD, government, and state, local, territorial, and tribal customers. Dr. Groves is DITR's primary representative to the FEMA-led Interagency Modeling and Atmospheric Assessment Center and leads DITR's efforts as the IMAC Technical Operations Hub. He oversaw the transition of the Technical Operations Hub to DITR in 2012, with DITR assuming responsibility for coordinating and disseminating responses to urgent requests for hazard modeling support 24/7. He's also the primary DITR POC to the Secret Service-led Multi-Agency Coordination Center during national special security events in the National Capital Region. He earned a BS in Atmospheric Science from the University of North Dakota and an MS and PhD in Meteorology from Florida State University. So, Dr. Groves, welcome. Thank you very much, and the floor is yours.
Okay, thank you for that introduction. So we're here today to talk about the Interagency Modeling and Atmospheric Assessment Center. So the thought behind this is, when there's a large hazmat or a toxic airborne event, how do people react to that, and what tools are available to kind of predict, how big is this mess, how bad is it going to be, and where is it going to go? So the history of this this group goes back to 2002. There was an exercise, national level exercise called Top Off 2, and one of the scenarios involved an RDD, a radiological dispersal device, in Seattle. And at the time, during the exercise, the governor of Washington was given a couple of slides from different groups showing where the predicted radiation was going to go. And one slide had it, one one model showed it going, say toward the northwest, and one model said, hey, it's going toward the east. So, the governor's up there holding these things up and says, what am I supposed to do with this? So that was kind of embarrassing, and because of that kind of spurned into action, answering the question or asking the questions of, well, who does this kind of stuff? How do we prevent that exact situation from happening again? How do we collaborate to where, different models, if they're showing different things, where people can say, well, this is why I think it's going this way, and this is why I think it's going the other way, and then figure out how to get it to where there's just a single model coming out, especially from the federal government. So DHS was given the task of figuring this out, and DHS was fairly new at the time. The task was go out and figure out, who in the federal government has these capabilities, who can produce these models, what are their capabilities, how robust are the models, are they 24/7 or are they on call, who are their customers, is this something that your different agency is going to wants to be involved in, and then come back and say, how do we make this work? How do we get it so that all the different groups that perform this kind of modeling can kind of work together and put out a single federal product in the event of something, a disaster. A lot of times our target audience is really anybody who is in a position of consequence management, somebody that's going to make decisions on, evacuating people or blocking off roads or sheltering in place. Those local communities that need to know that information, the idea is to get the information as quick as possible to those people so they can make wise decisions. So, we list that 877 number there as that's kind of like the 911 for Bernie events, chem, bio, rad, nuke, explosive. Call that number, and that goes directly to the DTRA Operations Center. And if you say, requesting an IMAC activation, then we go into production mode and we take all the information, create our models, distribute them, and then have a discussion about them. Let's go on to slide 2. So the IMAC mission is what I described. So providing a single point for the coordination and dissemination of federal dispersion modeling and hazard prediction products. So that means there's a single belly button, not only to create a model, but to coordinate with the other agencies that are part of this mission as well. And that product will represent the federal position during actual or potential incidents involving hazardous atmospheric releases. So that means that we do both, no kidding, there's a smoking building or a smoking hole and we've got stuff coming out, or, something might happen. An industrial plant is having has a leaky pipe or a rusting pipe or some malfunction that they believe could lead to an atmospheric release. So, we're there for both things. We're there for 24/7 to take calls from anybody that has those type of questions, that they have, something that's either imminent or something has happened, so that we can produce a model and get them out as quickly as possible. Let's move to slide 3. So IMAC is a partnership between currently 7 federal agencies. The lead is FEMA under Department of Homeland Security. DHS had the stick for several years, and after a reorganization in 2014, they passed the program to FEMA. So FEMA actually runs the IMAC program. FEMA has a National Watch Center. It provides 24/7 situational awareness, and understanding of any events where coordinated federal response is necessary. NOAA, obviously, any model is going to have assumptions in it, but if you don't have the weather right, the model is fairly worthless. if you have everything else right, you have all the chemicals, the amounts, the release time, all that stuff, it's still not good enough if you don't have the weather right, whether that means taking an observation or using a forecast to figure out where the stuff is going to go. That's vitally important. So NOAA, headquarters, the regions across the United States, and all of the weather forecast offices are all part of this mission. It's a big group, so it's we're still working out the kinks with getting the forecast offices on board, but they do, they run their own model, and we get the weather from them as well for the other models. NRC, the Nuclear Regulatory Commission, they are primarily interested in nuclear power plant incidents. They want to make sure that they control the messaging if there were to be any type of incident at a power plant, so that if we're putting out a model, that it's not, it's matching the messaging that's coming out from that plant. So, they're not going to get too involved in train derailment or tanker overturn, but in terms of nuclear power plants, they're going to take the lead. EPA is both a customer and a user, and a producer. So they produce the Aloha or Cameo and Aloha suite of models that are used by many first responders. But I would also say that probably half of our activation requests come from EPA on-scene coordinators as well. So those are the folks that kind of ride in after an event has started to kind of determine, do they need to take atmospheric model or monitoring, figure out, if it's going to be a long-term event, if they need to be involved. So they are a pretty big customer in this, in the activations that we've had. Department of Defense, that's where I fall in. So I, under the Defense Threat Reduction Agency in Fort Belvoir, Virginia, that's where the 24/7 operations hub for the IMAC takes place. So we're under an interagency agreement with FEMA to run the 24/7 effort. So we produce the majority of the models that come out, especially for fires or chemical events. Department of Energy is going to take the lead on radiological and nuclear events. The NARAC is out at Lawrence Livermore in California, and under the DOE's NNSA, they are the primary for rad nuke modeling outputs. So that's probably who's going to, if you have an event like that, that's who is going to produce the model. And finally, Health and Human Services is primarily a user of, they consume the IMAC products and then coordinate and disseminate data to their ESF number 8 partners. They will take a lot of the data and have to make decisions on infrastructure stuff. Do they need to send COTS? Do they need to send decontamination equipment, people, other resources? They take what the IMAC model suggests and makes decisions on whether or not to send things out. Moving on to slide 4.
Dr. Gross, do you mind answering a question now?
Absolutely.
Okay, because this one, I don't think it's going to be answered later in your presentation, but it comes from Michael Hallman, and his question is, I was under the impression that NARAC did all radiological plume modeling. So IMAC feeds metadata to NARAC to give us a plume for ingestion pathway exercises.
So, okay, so I'm trying to understand the question. So NARAC is at Lawrence Livermore National Lab. They are the primary for radiological and nuclear modeling. So, give you an example. So if we do a lot of these large-scale exercises that have either radiological or nuclear output. So we get in touch with, if somebody calls us for modeling during those exercises, we get in touch with DOE and NARAC to produce that model. They run their own model with inputting or ingesting weather, whether it's observations or 3D forecasts. So they have their own means of getting weather to input into their model. I'm not sure if that answers the question.
All right. Well, thank you for that. Certainly, Michael can either pose another question or put something in the attendee chat, and I'll check it out to see if he has any clarification. But for now, I'll move on to slide 4 for you, Dr. Rose.
Okay, thank you. So within that 7-agency group, somebody has to take the lead in terms of answering the phone calls, doing the coordination, producing the models, and kind of running the event. So as FEMA does not have their own native modeling capability, so that responsibility falls to someone else within the group. And that has been at DTRA since 2012. So we're responsible for coordinating the production of the model. So there's different groups that are going to take the lead. If it's chemical or fire or water, well, not waterborne, the DTRA is going to take the lead using our HPAC model. If it's, as we say, if it's nuclear or radiological, IMAAC and DOE is going to take the lead. So whoever produces the product, DTRA is still responsible for coordinating the messaging to send out the notification that IMAC has been activated, to let them know where to find the modeling products, and to, we usually have a discussion after the modeling product are sent out. So we control all that kind of messaging to let people know what's going on. We're staffed 24/7 by ChemBio, Rad, Nuke, explosive subject matter experts. So if somebody calls at 2 in the morning on a Sunday, there's smart folks there to answer the phone and to ask the right questions and to get the right information. This is not an answering service saying, we'll get back to you the next business day. This is, you'll actually talk to a chemist or a nuclear engineer or a structural engineer. Somebody like that is going to be there answering the call. Our goal is to turn around requests as quickly as possible, because we understand that if somebody's calling us, the last thing they want to do is wait around 4 hours for a modeling product. The event might be over by that time. So, in chemical situations or fires, our goal is about 30 minutes turnaround time from the time that we hang up the phone with the requester after we get as much information as possible to the time we distribute the model. We shoot for about 30 minutes. And we have a number of different decision support tools and models to assist our customers. So if it's not something that is in HPAC's wheelhouse or at DTRA, if we need to enlist somebody else within that group, there's numerous tools to help us. Next, slide 5. So how do we help? So the big thing is characterizing the incident. Is this, based on the information we're getting, is this something that's going to shut down an entire town or half a state, or is this something that a few neighborhoods are going to need to be notified? Understanding that the potential for danger and understanding interactions, such as that little circle there on the left where it says characterize the incident. That was one of our bigger incidents. It was in Maryville, Tennessee. So there was a train derailment. Well, actually, it was not a derailment. It was an axle that had broken loose and punctured one of the tanks, and the tank was leaking a certain chemical onto the tracks. So there was no derailment; it was just leaking onto the tracks. The problem was, it escapes me the chemical that it was, but we knew we had chemists on board. This is at 1 in the morning when we got the call. They knew that chemical, when exposed to air, was going to turn into hydrogen cyanide. So they were able to tell the people there that, look, this is a different beast that you're dealing with. This is hydrogen cyanide, not necessarily the chemical that's leaking out onto the tracks. So that's kind of the advantage that you get, is that there's people there that are experts at this stuff. They kind of know, okay, you tell me one chemical, we might know how it's going to behave when it leaks or burns or whatnot. Predicting the likely course. Where is this stuff going to go? And possibly where did it already go? Using the weather. So having access to forecast weather, observations. We know a little bit about, different weapon systems and stuff like that. That's primarily for the DoD side, but taking all that stuff into account, the terrain, the environment, the weather, and try to assess where is it going to go and possibly how bad is it going to be for the local population. In terms of managing federal resources, the IMAC program doesn't necessarily manage resources in terms of sending money or deploying people. It's the fact that you can take the IMAC models and make a decision on what your group needs to do. Does EPA need to send air monitoring? Does HHS need to send places that to set up cots and stuff like that at a resource center? So yeah, it's not in terms of distributing money or sending people. It's really taking our modeling products and making the decisions on what you need to do with them. And then finally, we talked about assisting with exercises and planning. So this is not just strictly, for real world events where there's actually something going on. To give you an idea of the scale, we respond to somewhere between 6 to 10 activations a year. So this is not something that's incredibly overwhelming. But we also, we push the idea that, we help with exercises and planning events so that people can kind of get used to what they're going to see with IMAC. What's the model going to look like? How are you going to interpret it? What's the process for requesting assistance? So we encourage people to reach out and have us be a part of their planning and their exercises. We might, if it's something where people are trying to design a scenario, but make sure it goes in, it doesn't go over a school or a government building or a church or something like that. We can help with that. We can help, the simulation cell and give you the most likely scenario projections. If it's something where you're trying to make sure that you're not killing thousands of people in an exercise scenario, but confining it to a couple of city blocks, we can help dial back or dial up the scenario to kind of help you reach your goals there. We'll move on to slide 6. So that's how we provide atmospheric modeling support. So we, real world events. So we're on call for, national special security events. We were on call for the Super Bowl, meaning that, we didn't have anybody specifically there, but we knew, we had the models running. We were kind of monitoring any traffic going on during the event, anything here in the National Capital Region, inaugurations or State of the Union address, stuff like that, having just being at the ready and to contact our partners in case something does actually happen. Get involved with some of the smaller and bigger exercises, something like Gotham Shield a few years back, which was a pretty large exercise, Marble Challenge, any of these major exercises we either get involved with during the exercise or do some of the pre-production of the scenario beforehand. And we also provide training. So webinars like this where we give an overview of the IMAC program. There's classroom training for the HPAC model in the National Capital Region. If you want to get an idea of how does HPAC work, what inputs do you need, what does the output mean, that kind of stuff. There's classroom training available for that. Next slide, number 7. So in terms of the modeling tools, so there's modeling tools available for chem, bio, radiological, nuclear, and also explosives. So for DITRA, HPAC covers the vast majority of these things. But we also have, EPA has Cameo Aloha Suite, which is on board most first responders' vehicles. High split is actually NOAA's tool at all the weather forecast offices that they can run that. Bio is a different beast. It might not be necessarily something that, you're going to get a 30-minute response for. A lot of bio incidents, you may not know that something happened for a couple of days until people's symptoms show up. So we treat it a little bit differently, and luckily we've never actually had to activate for a bio event. We've certainly gotten calls about, envelopes with anthrax or ricin or something like that. We've gotten calls about, but never actually activated for bio. But we do have the tools available if necessary. Rad nuke, as I mentioned, DOE is going to take the lead. HPAC also has the capability to model that. And if it's a nuclear power plant, NRC runs a tool called RASCAL, which takes into account the different radionuclides and stuff that could be released. And that gives a source term, it gives an idea to the other models to kind of take that and run with it in their own models. And explosives, thankfully, we've never been activated for an explosive either, but we do have the capability to run a couple of different codes based on the type of explosion or type of explosives available and all that. Let's go to slide 8. So one of the things we kind of stress to our customers is that IMAC is a free service. You'll never get charged for calling IMAC or requesting anything for an emergency or an exercise or a plan. There's no charge for that at all. And the other thing is that we don't want to come off as like, well, this is now the federal response, so you need to use this model that we're sending you instead of whatever you're working on. It's never the case. We stress that IMAC is a tool that can be used. It's a tool in your toolbox. There's other tools out there that might be faster. There's nothing wrong with using any of those either. And a couple of those are what we mentioned here. Like Wiser is a tool. It provides a range of information on hazardous substances, identification of substances, physical characteristics, human health information, and containment and suppression advice. And it's fairly rudimentary, but it does give you an answer pretty quickly. Cameo and Aloha and Marplot are EPA tools, and pretty strong. Cameo has a chemical database of over 6,000 chemicals and product trade names. Has a search engine, including information on fire and explosive hazards, health hazards, firefighting techniques, stuff like that. And you plug that stuff into Aloha, and you can get, Aloha just has uses a single weather observation. So you just tell it, winds from the south at 10 miles an hour. It also, it only has a range of about 6 miles. So but the plot comes up instantly. So you put in the information you have, and you can get a plot in 10 seconds. So it's very quick. It doesn't have a long range, and it's probably best for like a small event. But it is a quick tool that's available for most first responders. So the difference is, IMAC is the one that you see on the far right. So that's coming out of HPAC. So that's giving you a more robust model. It's going to take into account three-dimensional weather, turbulence, a lot more about the specific source release, like whether it was exploded, leaked, burned. It gives you information about the number of people that could be affected, using like acute exposure guideline levels, giving you an idea of how long was this an event? Like if it was something like chlorine, was it mostly people affected in the first 30 minutes and then mostly gone and dissipated after that, or is this something that's going to linger over hours and also over longer distances? IMAC is the HPAC model runs. You can set up a model to run hundreds of miles if you want. So if it's something that's really big, we can handle that instead of Aloha. So the idea here is not to say that IMAC is you need to use us, but it is a better, more robust model than the other ones that run quicker. Going on to slide 9. This is just kind of a rundown of what I'm talking about. So, Aloha, Cameo, Wiser, greater simplicity. You don't have to know as much in terms of inputting data. It runs, they run instantly. They make a lot more assumptions about the weather and the terrain. And it is good for small scale, short-term stuff. So less than 6 miles, shorter output times, maybe an hour or something like that. But what you're missing there is, HPAC is going to better capture the transport. It does take a little bit longer to run because of the input requirements and the weather that you use. But it is more specific to that incident. It has the population models that can give you, is this something that's going to affect 5 people or 5,000 people? And it's good for long scale, longer term incidents. So if this is something like a tire fire or something massive that's going to take, hours to days, HPAC is probably going to provide you a better answer. So overall, the idea is, use what you have, but we're there as another tool for you in your response. All right, let's move to slide 10. Just a quick, we stress to people, to first responders and stuff, that the best way to get in touch with us is that 877 number. We don't want people bothering with filling out a form, scanning it, faxing it, whatever. The best way is for us to hear from you directly and to get all the information that we can get directly over the phone, so that we understand, everything that they're telling us. So we ask when these people call, we're going to ask the basic questions. When did an incident occur? Where did it happen? Do you have an address? Do you have an intersection? Do you have coordinates? What is happening? Is it something that exploded? Is it something that leaked, something that burned? Any ideas about the type of material involved? And of course, their contact information. So in case we do get, the last thing we want is to get all this information and not know how to get in touch with the requester again, in case there's questions that come up. Did you say chlorine or did you say ammonia? Or, making sure that we have the right, 6th digit on the latitude or something like that. We want to make sure we can get in touch with them. And this is available for any federal, state, tribal, territorial, and local official. Anybody that's involved in some manner of response, decision making during incidents like this can activate IMAC. So it's not just, it has to be an EPA official or something. This is anybody that's involved in a response can request the IMAC. Let's move to slide 11. So, in terms of how do we activate? So once somebody calls that number, that 877 number, and says, I'd like to request an IMAC activation, then we go into production mode. We take down all the information, ask all the right questions, and once we hang up the phone, then we initiate, product development. So, say you're at DTRA at the Technical Operations Hub. So somebody's, looking up the address or the coordinates, finding the right building or intersection. Somebody's starting the model. Somebody's starting the GIS products. Where making the pretty picture and stuff like that. Once we're done with that, we distribute the products. We let everybody know that the product is done, where to find it, and then about 20 to 30 minutes after the product is done, we like to have a teleconference with everybody involved so that we can kind of go over, what's happening, what's the real world situation. Are there people, have been evacuated? Is there anybody injured? Is there like a command post set up? Stuff like that. We'll, give information about that, and then we'll talk about the model that we produced, what it means, how to interpret it, getting input from NOAA on the weather. Do they see this? Do they see weather changes coming over the next few hours if it's something that's going to be long term? And then kind of make a decision from there. Do we stay activated? We leave it up to the requester to determine what the next steps are. Do they want to keep us open, keep us working? Do they want an update in a few hours, overnight? All that kind of stuff. And finally, we don't deactivate until the requester says, "Hey, we're done here. The fire's put out. We're good." We don't deactivate on our own. We let the requester kind of guide us through. They're ultimately our customers, so we want them to make sure they got everything they need before we wrap it up. Slide 12. So we'll kind of go into an example of how this actually works. So this was kind of our big, a big activation that involved a lot of people and had actually got quite a bit of notoriety. So this was the Arkema chemical plant in Crosby, Texas. This is 2017. Let's go to the next slide. So what happened was with Hurricane Harvey, it was just sitting and dumping water over southeast Texas for days. So there were certainly areas all around Houston, all around that southeast coast that were just getting pummeled with water. And this chemical plant was no exception. So what happened was they had organic peroxides on site that needed to be cooled. The problem was they were starting to, they ran out of power, there was flooding, they had to make a decision on what to do, and they originally had moved these peroxides into 10 outdoor trailers that were cooled by diesel fuel. The problem was that they knew that they were starting to run out of fuel and they had a problem on their hands. So they were concerned that these trailers were going to either spontaneously combust or go on, light on fire. And they knew, so this was one of those situations where they knew that nothing had happened yet, but they knew something was coming. So they called us, EPA Region 6 called us to activate, and we kind of went into production mode from there. We talked with some partners saying, well, okay, we're talking about 1 million pounds of peroxide. How bad is this going to be? We had a lot of interagency participation between FEMA and EPA, NOAA, NORTHCOM, Joint Task Force Civil Support, Health and Human Services, and TRANSCOM. A lot of people involved in this and took our modeling products and ran with it for their own, to support their own customers. Slide 14. So over the course of 6 days following activations, there were 3 trailers that did combust on their own. Luckily, I don't think there was a massive explosion, but they did go up, and they decided to intentionally destroy the rest of them over a couple of days because they knew there was nothing they could do to save them. So they wanted to kind of control the environment in which they went up. Evacuations were conducted a 1.5 mile radius around the plant, even though a lot of people had already evacuated because of the flooding. But just to make sure that, whatever was coming out of this plant, they did not want people around it. And we provided, after that first product, we provided 9 updates over the course of the 6 days. So we would get updates from EPA daily and then run new models depending on what the new information was that was coming in. So the products that we modeled were explosion of those organic peroxides, potential for chlorine release, which luckily did not happen, but they were concerned with an explosive that would rupture the nearby tanks, which it had chlorine, sulfur dioxide, isobutylene, and then they were also concerned about the vertical. This plant was getting a lot of media attention, so there were a number of media helicopters that were circling the plant while this was going on. And so they were, wanting to know, hey, should these people be doing that? Is this a hazard? This stuff that's burning is probably hazardous, and they shouldn't probably be sending helicopters. So they wanted to get an idea of how far up was this going in the vertical. Slide 15. So, this is an example of what our modeling product kind of looks like. So what we try to do is on each Most of the time we're building a PowerPoint slide or a PDF, and it's going to give you a two-dimensional representation of where the stuff is, where we believe the stuff could go, on a kind of a 2D projection. So, in this case, we were modeling potential sulfur dioxide. So for this model, it looked like the winds were coming from the southeast, pushing towards the northwest, resulting in acute exposure guideline levels of 3 and 2, which were, anything in the red, we believe, if you're sitting there exposing yourself to it and not moving, death is a possibility. The orange contour means Eagle 2, which means you might possible irreversible damage, to your lungs or whatever, depending on the chemical. So we try to provide all that stuff on one slide. What's the location? What was the time of the release in the model? What's the chemical? What's the amount? How long did the model run? And then information about, we typically provide population statistics here. And in this case, I don't think we did, because we knew that a lot of the population had already been evacuated. So this was more of a, just kind of showing where it was going, instead of being too concerned about the population numbers. Next slide, 16. In addition to the chemicals, then we also took a look at the explosive potential. So this is a look at range rings for the explosion. So we converted the organic peroxide into a TNT equivalent, and then ran a model to show how far out explosive elements could be, usually by PSIs. So we're talking both human injury and structural damage. So this is damage to lungs, to eyes, to eardrums. What kind of facilities could sustain architectural damage and stuff like that, all included in this kind of one slide. Luckily, that did not happen here, but we wanted to at least give them an idea of, okay, if that full amount goes up at once, this is how far out people could be affected. Slide 17. So, going back to the, taking a look at the vertical extent. So if you look at the two-dimensional representation, it doesn't look like, this is affecting much more than just, part of the industrial plant. But if you're looking at vertical, it certainly is going, we predicted, soot going more than a mile up into the air and being carried from east to west for this particular update. The hazards are, not entirely descriptive in terms of hazardous, unhealthy, stuff like that, but at least it gives you an idea of where places should be avoided. So this at least gave them, the idea that, look, people should not be circling this with helicopters. I understand this is a news story, but the last thing you want is people to be exposed, up in the air. So those are the type of things that we present, and we try to contain as much information as possible, and show, talk about our assumptions, because every model is going to have assumptions. Try to contain all of that in the model that we send out. Slide 18. So when we talk about, partial activation, so instead of something being, actually on fire or actually spilling, we talk about this idea of, well, we'll activate, but just for, the potential for something to happen. So this is anything that could happen or is likely to happen. So what we will do in those cases is provide a hypothetical release specifically to the requesting agency, but we don't necessarily activate the entire IMAC community. We've kind of learned our lesson in the past, instead of creating hysteria about, something that's actually happening, we limit it to just, well, we'll give a what if. What if this happened? What if this amount of stuff was released? So a couple of examples. There was a controlled burn in Wisconsin where, so there was a number of chemicals. There was a man that had an apartment. He was killed in an explosion. Turned out he was kind of a hoarder and I don't know, somebody that just wanted to work with chemicals. So he ended up dying in an explosion. Um, and the firefighters determined that it just wasn't safe for people to go into the building because they into that apartment. They weren't sure what was in there. Um, they didn't want to set off another chemical event or an explosion. So they ultimately made a decision to set fire to that building, just to eliminate the threat of chemicals inside. So they were kind of working with us on when is the best time to do this, to keep it away from, to have the right wind conditions, the right time of day to keep it away from the local population. We also had a potential ammonia release in New Jersey. So there was a refrigerated storage company found to have problems with their cooling systems. So they knew that there was a pipe that was likely to either rupture or fail. So for about a month, we were providing like daily updates on, okay, if that pipe were to go today, here's where the ammonia could go. So there were a number of, dozens of people that were evacuated for quite a while during this incident until they finally got it resolved. And then finally, in Michigan, there was a pool sanitation factory that was shut down. The regulators said that, the company there was a leaking roof, there was open sacks of an acid on the floor, acid dust, and it generally was unsafe. And the concern was, okay, if there's rainwater that get in and mix with some of this acid and this dust, you could have, a potential explosion or release of chlorine. So we kind of helped with giving an idea of how bad it could be if a certain amount of water was to get into that facility. So that's, just kind of give an idea. We're available for not only something's actually been released, but, things that could happen as well. Moving on to slide 19. So where do we put these products? Right now, we're kind of in a transition period. We've posted products on the Homeland Security Information Network, which is a SharePoint site, for many years. We have our own community of interest in there. We post, real world products, exercise products, GIS products like shapefiles, KMZs, the PowerPoints, the PDFs, all that stuff is kind of contained in there. We are currently transitioning over to FEMA's Suburban Responder Network. There's going to be an IMAC portal in there that's it's up and running, and we'll probably be open for activations later in the spring. But it's just, we're in transition. But the point being, when we produce these products, we will get them to the people that need them, however they need it, whether it's email or posting it somewhere or something. This is just where we keep a repository of our products, in HISN right now. But we do make sure that the requester is the ultimate number one during the scenarios, and we will make sure that they get what they need when they need it. Slide 20 is kind of just a wrap. In terms of contacting us, for emergencies, that 877 number again is kind of like the 911 for chemical events or suburban events. We encourage people to call that number during an emergency. Don't worry about finding an email or finding a form to fill out. Emailing IMAAC@fema.dhs.gov is the way to get more information, figure out how do I have an exercise coming up, how do I get IMAC to be involved? If you have basic information or questions about IMAC, that's the best way to get something during, non-emergency time. Just general inquiries and support requests, use that email. And there is a public website that has more information about IMAC at the dhs.gov site there. And that's really a wrap. Now I'll certainly have time for questions.
That's great. Thank you very much. I do have a few questions in here. A couple may have been answered, but I'm going to put them up there anyway. So for the first question came in earlier. It says if if all models are wrong, but some are useful in quotes, how does IMAC and NARAC ensure that plume modeling results are correct/valid?
So
Matt?
that's absolutely true. I mean, there's no question that the model is only as good as the information that's going into it. So between like NARAC has their own means of doing verification and validation of their model. HPAC has certainly been through a lot of V&V work as well with different, the Oklahoma City experiment, the New York City experiment, experiments out at like the Nevada test site using chlorine. There have been a number of models or like experiments that have been used to simulate releases where most of these models have been validated or verified. But it is ultimately, when you're talking about no kidding, something just exploded or is on fire, it's only been going for 30 minutes. It's a little hard to make sure that everything is absolutely true because once again you don't have everything you need. You don't have all the information right away. We do the best we can with the information we're given. So it's really meant to be not an absolute like, okay, this side of the street is okay, but this side of the street needs to shelter in place. We're not meant to have that much that level of fidelity, but it's intended to be a tool to say, look, more than likely, we believe the contaminants or the hazmats are going to be going in this general direction. So if you want to set up a command post or you want to notify residents, most likely it's going to be in this specific direction. So we don't necessarily have sensors out there. We don't have out there to validate the models in real time necessarily. A lot of times this is like something just happened and here's our best guess as to where it's going to go and how many people can be affected. We're not going to say that it's absolutely going to be 100% right, but it is a tool for first responders and on-scene coordinators to use to make the decisions that they are going to make.
Okay, thank you. And then as kind of a follow-up to this, the same questioner, which is Lowell Ralston from the EPA, actually, listed a few of the different models that are used. Such as NARAC uses the ADAPT Lodi model, DTRA uses HPAC, etc. This question is, has IMAC compared results from these models based on past events to see which models perform the best?
The thing is that a lot of times we may not be modeling the same event. So it might be something where, if somebody calls us, it might be only one agency that even really knows what's going on. So a lot of times if we get a call about, a lot of our activations are a building fire. A lot of them are these like industrial or like recycling plant fires recently, which is kind of surprising, but there's certain agencies may not really, especially if it's not a 24/7 thing, they may not model it, and it might be just HPAC. There's only a handful of events, I think, where multiple agencies have modeled the same event. What we try to do, a lot of times it's not going to happen in a real time situation. We might not do a lot of validation during an immediate response, but we might work with them after the fact and see where what assumptions were made, what weather did we use, did we use the right model, did the right weather model capture the weather of that event, or did we use should we have used a different one? It's kind of working with the different agencies to specifically look at, how did we respond and did we do things right? It's just that we don't have that, there's not that many opportunities to where multiple agencies have modeled the same event.
Okay. All right, the next question comes from Donald Ponikvar. Said, is HPAC used for biological threat plume analysis? And then follows on with, who makes the call which decision support tool or model is appropriate for a threat that is evolving and may not yet be fully defined as chem versus bio versus rad?
So HPAC does have the capability to do biological threats. I think that there's somewhere in the ballpark of like 8 to 10 between anthrax, plague, ricin, a number of different biological agents that HPAC models. So yes, it is used for bioanalysis. Who makes the call? So this is kind of a perception about how this works. Ideally, in a perfect world, you'd have all 7 agencies or whoever models producing a model all at the same time, come back, an IMAC guru looks over all the models and said, this is the one we should use. Unfortunately, that's just not the case. It's a lot of times it's about it's about speed versus making. It's about you have to balance between getting a response as quickly as possible to the person who's asking and the collaboration process. So a lot of times, I would say the vast majority of the time, when that IMAC call comes in, it's more than likely going to be DTRA's product coming from HPAC that is the first model coming out. Unless we specifically know if it's something like RadNuke, we will call DOE and we will get NARAC spun up as well. If it's waterborne, we will call EPA or NOAA, depending on which situation. Is this a river or coastal, something like that? We will make the call that those groups are responsible. But if it's just something that like, hey, this fire is going, or this thing just exploded, a lot of times what we will do is produce a simple, like, call it a smoke model. Like, if nothing else, if we have no other information, we just put in where it happened, when it happened, and release soot, release smoke, so that at least we have, at the very least, an idea of whatever contaminants, okay, it's going towards the northwest or it's going towards the southeast, so that people at least have an idea of, if something is coming out that's dangerous, okay, we have at least a direction of where it's going. And then we always can follow up with better information and a better model as more information comes in. So that's kind of the first thing, is to put out something quick, which might not have a lot of information, but it's something to give first responders at least an idea of where this could be moving.
Great, thank you. Another question from Donald Ponikvar. He says, DHS, through both the Counter WMD office and DHS S&T, have worked hard on plume models for urban environments. How does IMAC deal with threats in that specific environment, since neither HPAC nor NARAC were really designed for a true urban canyon environment?
That is true. So I would definitely say HPAC has struggled for years on urban modeling, going through different models, different urban models, trying to find the right combination and make it work within the architecture. It's been a struggle. NARAC does have, and DHS funded, I believe, something called Aeolus, I believe, which is more of an urban look, and it certainly shows promise. I don't know that I'm not sure if it's ready for prime time yet. I'm not sure to what extent they're using it, but that is probably the best thing we have going. But it's just currently it's tough. I would say the urban canyon environment is difficult. A lot of the models that run those things are long running, and it might take, they're very robust, and they might take a long time. So again, you have to kind of balance out, the person that's answering the question, how long can they wait for an answer, versus just getting something that maybe doesn't necessarily, represent the urban canyon environment perfectly, but at least gives an answer, at least gives something to work on until we can get results from those more robust models. But I would say yes, urban is tough, and it has been tough for a while.
Okay, great. So we're at 1300. Dr. Grove, do you have time to continue answering questions? We have a few more.
I do.
Still on this. Okay, great. Yeah. Then we'll keep going. To any of the users, if you have another engagement and need to drop off, this will be posted online. And but I'm going to continue working through the questions here then. So the next question here from Eric Pohl, does IMAC have any experience with in situ burning of oil as a spill response tactic? Could a predictive model be generated to understand VOC and smoke migration in advance of and in support of an operation like in situ burning?
So we do have some experience there. Yeah, I'm just reading through it again. So yeah, we've had instances where somebody has called us and said, look, something is, we're either going to intentionally, burn something like these stump dumps, or in certain situations, like in the Caribbean islands. These may not have been specifically IMAC. They may have been more like from a ditcher perspective, but like areas that have been hit by a hurricane, and there's just debris all over the place, and they decide to burn that, and make a huge burn pit and burn it. They'll contact us to kind of figure out which day should we wait for a certain day to do that, to keep it away from the public. In terms of oil, we do have the capability to model burning oil. I don't know that we've necessarily done a lot of activations with it, but doesn't mean we certainly can do it. It's just that we haven't done a lot of it. And we have done exercises with folks too, in terms of that, like with Coast Guard, kind of simulating a spill off the coast of New Jersey or Delaware. They have included us in an exercise to do, an oil spill, and what if they were going to burn it, what's the thickness of the oil, what's the type of oil, get an idea of where that smoke could go, and possibly saving it for a direction where it's maybe blowing out towards the water instead of toward the coast. Hopefully that answers that.
Great, thank you. This question from Oleg Pavetko at the EPA. Have you had experience modeling release of radon gas from storage of radium, where the source term gas concentrations can reach relatively high levels?
That is a pretty solid no. Again, not to say that we couldn't, but I just personally don't remember modeling that specific scenario. But we certainly have the capability and the background, subject matter expertise to try to assess that. I just don't know that we've had that exact question come in before.
Roger. So the next question from the same inquirer: do you provide a 2D plume map to RAD responder or CBRN responder?
So since we've just started, probably in the last 6 months or so, within CBRN responder, which also houses RAD responder, Chem responder, and there's the new IMAC portal inside that CBRN responder suite. So one of the things that we've gotten to do now, I would say that we personally, from a ditcher perspective, we haven't done a lot with Rad Responder. I know that NARAC and DOE does do a lot with Rad Responder. So I believe they do have that capability. So with the IMAC portal, we're just kind of getting started with this as well. So what we do is we can, if we run a model, we have the capability to post the GIS file. So whether it's a shape file or a KMZ or KML, if we post that within the IMAC portal, so if somebody goes in and makes a request, gives us all the incident details, if they share with us, and I know Duggar from FEMA is on the line. If I'm not sure if he can weigh in, but if they share with us, like if you create a scenario or an incident within those tools, and they give us the name, they allow us to link to their event, we can put those KMLs and KMZs into their map so that they will show up on a two-dimensional map. So it's a matter of coordination. It's the answer is certainly yes. It's just a matter of coordinating with the requester to make sure that those GIS files go to the right map and show up in their event that they created in those tools.
Okay, sounds good. So that kind of leads me back to a follow-on question that Michael Hallman asked in the chat. He had asked an earlier question, and I guess he's curious or concerned about how IMAC is fitting in with the Rad Responder portal. And his question is kind of, I would think NARAC would be a better fit to be able to get KML layers instead of IMAC. I think he's specifically meaning in that Rad Responder portal. Is that correct for now, or?
Well, yeah. So NARAC, I believe, has been working with Rad Responder for years. So they are far more well versed with posting stuff to Rad Responder, uploading things than us at DITRA are. But with this new IMAC portal, we'll be on the same framework. So we can be producing, IMAC models will be posted in the same manner. It's just again a matter of making sure that we interact and communicate with whoever's requesting the model, so that we can post it to the right spot so that it shows up in their maps. But yes, there is definitely a history there. NARAC has that history with Rad Responder, and they work with it all the time.
Sounds good. And I think you actually touched on this a bit. This question is from Sam Keith. It says, does IMAC ever compare their initial estimate against the final result in an effort to inform the modeling?
So yes, we do. If we can get, the problem sometimes is just getting the final result. Sometimes we get activated for things that don't necessarily have a lot of follow-up. It might be something that, we get a call and it's a fire and it's put out almost shortly after we get activated. I mean, that happens quite a bit. That's a good thing, I guess. But we do go and, we do search out to see if there's any reports or anything filed about the incidents that we activate for, so that if there are readings taken, anywhere where they might have been able to kind of take, samples, readings, and see if our models did, show a similar result. It's something we absolutely want to do. It's just a matter of finding either the right result, the right summary package, or finding whoever produced that. Sometimes that's the hardest part, is figuring out, well, who did do the result, and are there data that can help us do that, comparison. So the answer is yes, we absolutely want to, and we have done it for a couple of events, but it's sometimes just a matter of finding the final reports or results that can help us do that comparison.
Great, thank you. And then another question came in from Gavril Mikas. It says, is it possible for IMAC to be used in a rewind process scenario in order to estimate the initial point of an event for law enforcement activities?
So that's a fairly loaded question. The answer is it's possible, but it's not. So the way that most of these models are built is, I would say between HPAC, NERAC's model, high split, even something like Aloha, they're almost built to be source term driven. So you tell us where, when, what, and how much, and give us the weather, and we'll tell you where it's going to go. So there are, there's a handful of models that do the reverse. And if they don't, trying to kind of engineer that process, that rewind process, is somewhat difficult, and it takes a bit of skill. And an example of this would be the BioWatch program. So DHS has run the BioWatch program for years, and for a number of years there was a manner of I think it was Los Alamos that would run a model that did kind of that back tracing, trying to go from, okay, there was a sensor hit at this location, so where did it come from and how much may have been released. That's fairly difficult to do. So what we do try to do that a bit with HPAC, but it's not simple. So if we're given like a sensor hit, BioWatch gives you a sample of when something may have been collected, and I'm speaking above my head here in terms of bio, but like not necessarily an amount, but like a strength of hit on the sensor. So we will try to take, IMAC is, to be sure, we are not the modelers for the BioWatch program. What we try to do is help when we can. So, if they give us, one spot or two spots where a reading was taken, where a positive hit was on their sensors, we can try our best to kind of use, reverse the weather, and try to say, okay, well, if it did, try to narrow down at least, maybe not pinpoint to a specific building or location, but give a general area where it may have come, and like at a certain time. So I would say this part is quite difficult, but we do have kind of a means to try our best. And that's about, right now, it's about the best we can do. It's just that the models are not built to do that rewind process specifically, and it takes a bit of engineering to kind of do that.
Makes perfect sense. And this is, I think this is the last question I have in the queue for now, from John Dixon. And he's just asking, we're having an exercise in May of 2022. Can you notify users of the date this merger with FEMA Subernity takes place? And I don't know if you have a date right now, or if you have a plan for.
Yeah, so we are the IMAC portal in Suburban Responder is open right now. We have been answering. We've started taking exercise requests, planning requests. So anybody that has an account in there can go into the IMAC portal and make a request. We also have a form that if you respond to that IMAC at fema.dhs.gov, we can send you a form to kind of fill out like the basics of your exercise. When is it taking place? If you have any of the scenario details, your contact information, and we'll get back in touch with you. This is certainly, I think we're shooting for maybe the end of April to open it up for emergency requests. but we have been open for a while for exercise requests within suburban responder. But we can, whatever, if you have an exercise in May, we can absolutely help you with that. Either way, whether it's through the cameras or suburban responder, the IMAC portal, or just sending us a form with what you need from us, we can absolutely support that.
Well, that's great, and thank you so much for answering all those questions. That is all that I see. Um, you have a comment from James Justice. Says, as a prior user of IMAC products, thank you and great presentation, much appreciated. And I'd like to echo that thank you, Dr. Gers. That this was an outstanding presentation. I think very informative to our user base. Um, yeah, we have a big suburban type of user base, as well as just regular law enforcement, first responders. So I think this is an incredibly informative webinar presentation, and thank you so much for the presentation.
Absolutely. Thank you, everybody, for joining. This is part of what we try to spread the word. A lot of times people just have not heard of this program. And so, giving an opportunity like this, it's good for us to get the word out.
Absolutely. And I'll say I didn't hear about you guys until I went to a conference a few months ago, and I actually lost the business card of the person who gave it to me, and I reached out using one of the standard organizational mailboxes and got an immediate response. So you guys are definitely monitoring you're definitely 24/7, 365. So
yeah,
thank you for that, and thank you guys for everything you do. Appreciate it.
Absolutely. Thank you very much, everybody.